So first thing we're going to do is put it into slope-intercept form. Solve for y. Y equals mx plus b, whatever you want to think of. So to do that, you got to take and subtract the 4x first. Okay, and then we got to divide by 5. So y equals negative 4/5 x plus 2. Okay, now to graph that, you start by plotting your y-intercept. So you look at the b. So b is 2, positive 2. So I go up to 2 on the y-axis. Plot that point. It's right here. Okay. Then I use the slope. Slope just tells me directions to get from one point to another. So the slope is negative 4/5. So the negative always tells me to go down. Okay. You always go to the right. So always start by either going up and to the right or down and to the right. The only time I ever go left is when I run out of room going to the right. Then I go backwards and I go the opposite way. So if I'm instead of going down and to the right, I'm going to go backwards and go up and to the left. Okay? So if it's negative. Now, the other thing you should always check is, does my line make sense? Well, if it has negative slope, it should be doing what? Going down. And it is. Okay? So, does that ring a bell? We did this at the beginning of the year. Okay? Now, the reason why we're revisiting it is because we are doing solving systems of equations. So now we're going to have two equations. And we're going to find the solution to that system. So what is a solution to a system of equations? Yeah, the point that makes all of them true. Okay? Okay, so now, graphically, that's going to be where what? What am I going to look for graphically? The solution to a system. Or they intersect. Okay, so what I'm going to do is I'm going to graph each line individually and then see where they intersect. And that will be my solution. Okay? So what questions do we have on this? Alright, so that's what this is saying. System of two linear equations and two variables. So this is an example of a system. Two equations, two variables. Okay? That's an example of a system. That's all that's shown. Is there's a system. Okay, so a solution to a system is a point x comma y that has to work for both equations. It has to be true for both. Okay, so you got to plug it. If they ask if something is a solution, all you got to do is plug it in and see does it make a true statement for both of the equations. Okay, so the example we're going to look at, top of the next page, is negative 2 comma 3 a solution to that system. So says we got to plug it in and see if it works for both equations. So now remember, whenever they give us a point, what's negative 2? The x value. What's 3? The y value. So I'm going to plug those in. So it's going to be x, which is negative 2, minus 6 times y, which is 3, equals 20. So I plug them in. Then I simplify and see if that is in fact true. That's going to end up being what? Negative 2 minus 18 equals 20. So negative 20 equals 20. Does negative 20 equal 20? No. So once you get one that's not a solution, then you know it's definitely not a solution. Okay? So this is not a solution. Now, it doesn't matter if you plug it in and it works for the other one. It's got to work for both to be a solution. Now, once we start getting into three equations, three variables, you got to plug it into all three and see if it works for all three. Okay? Does that make sense? Because like if I plug this in here, 3 times negative 2 plus 2 times 3 equals 0. That's negative 6 plus 6. So it does work for this one, right? So what that means is that negative 2 comma 3 is on this line, but it's not on the other one. Okay? So it's on the one line, but not the other one. So it's not a solution to the system because it's got to work for both. All right. So directions are to graph, to solve a system by graphing. You graph each of the lines. Then you find out where they intersect. Okay, and then we can check it algebraically to make sure it works. Well, that's the check that we just did. Plug it in, plug your solution in, see if it works, make sure it works for both. Okay, that's how you check it. So we got to graph these. So first equation. Take a look, think about how am I going to graph that first equation. Hang on. So the first equation, what are we going to do? Let's see. Brian, what are we going to do to graph that first equation? Johnson. What are we going to do to graph this first one? Yep, we got to get it into y equals mx plus b, or solve for y. So we got to subtract 2x. Now, these are not like terms. You cannot do 4 minus 2x and come up with just a single term. Okay? Should write it as mx plus b. Well, it's positive 4, negative 2x. So now to graph this. Hey, well, how am I going to start graphing that line? For where? On the y-axis, yep. Because there's two different 4s that I could be, x or y. It's the y-intercept. 4 is the y-intercept. Okay, now, Nick, what do I do next? Okay, so we started the graph. What do we have already? We got that. So what's the next step? No, need to phone a friend? Phone a friend if you need to. Get your lifelines. Yep. So we go down 2, right 1. Why do we? Because that's the what? Yeah, the slope, negative 2. So negative slope's negative, so I go down into the right. Okay, so we got that one. Second equation. Jenna, what do we do for that second equation? Okay, start by doing that. For each of those, you only had to do one step to get y by itself. All right, Melanie, what do we do next? How do I start graphing that then? Positive 3 on the y-axis. Okay. What do I do after that? Dula, what do I do now? Down 1. Careful. Negative tells me to go down. Left would also be a negative direction. So negative over negative would actually be what? Positive, right? So when you go down 1, you should always go up or down and to the right to start. So I'm going to go down one and right one because my slope here is what? Well, if there's nothing written, it's a 1, but it's a negative 1 in this case. So I'm going down one, right one. If I can't go down into the right, I'm going to go what? The opposite of those, up and to the left. Okay? So hopefully we can see where those two intersect. Where do those two intersect? This point right there, right? So that point is 1, 2. That's your solution. Yep. Solution is where those two intersect. It's a point. Point of intersection. So now how can I check to make sure I did that right? Plug it in. I'm going to take the first equation, 2 times x, well x is 1, plus y, which is 2, equals 4. So let's see, 2 plus 2, well last time I checked, 2 plus 2 is 4, right? So that works. Go to the next one, x plus y equals 3. 1 plus 2 equals 3, so 3 equals 3. Yep. All right, what questions? Yes. What's that? Where those two lines intersect. So it's the point, always go left or right first. If I go to the right, it's positive x. If I go to the left, it's negative x. Up is positive y, down is negative y, right? So I went right 1, which is positive x, so positive 1x, up to positive 2y. All right? So now, how do I determine how many solutions a system is going to have? Well, there's a couple different options. So let's think about this. So what would my options be? Well, the solution is where they intersect. So if I have 2 lines, how can 2 lines intersect? How many times? Once? Never? Always. Okay? Which is the infinitely many. Okay, so there's 3 types. Lines intersect at one point. That's one solution. Okay, so if they intersect at one point, things we're going to know. This is the case where they're going to have different slopes. Okay? If 2 lines are changing at different rates, eventually they're going to intersect. Okay? It's like driving. I always equate it to driving in a car. So no matter where you start, if one person's driving at 40 miles an hour and another person's driving at 60 miles an hour, so is the one guy going to catch the other guy? Eventually, right? Okay. Now we're using a theoretical road that never ends, right? So eventually that guy will catch him. Okay. No solution. Okay, lines are parallel but do not intersect. Okay, so what do we know about parallel lines? They have the same slope. But different y-intercepts. So like driving in your car. So let's say I jump on the expressway. I'm a law-abiding citizen, so I set my cruise control at 70 miles an hour. Okay, 5 minutes later, Kyle jumps in his car. Jumps on the expressway. He's a law-abiding citizen. Sets his cruise control at 70 miles an hour. Will he ever catch me? Never. Because we're doing what? Traveling at the same rate. We have the same rate of change, which is exactly what the slope is. The rate of change. Okay, if they have the same rate of change but different starting points, they're never going to intersect. Infinitely many solutions. So this is where they're exactly the same line. So that means they have what? The same slope and same y-intercept. They're exactly the same. Okay, so when I solve for y, you're going to get the exact same equation, same line. So that's exactly what you're going to do. You're going to put it into slope-intercept form to determine how many solutions there are. Okay, so if they give me this example here, how many solutions is this system going to have? Well, so we got to put it in slope-intercept form to determine that. So the first equation. How do I put that into slope-intercept form? Yep, got to solve for y. Next equation. Second equation. How am I going to put this one into slope-intercept form? Add 4x. So it's negative 2y equals positive 4x minus 5. Then what? Divide by negative 2. So 4 divided by negative 2. Negative 2, negative. What's a negative divided by a negative? Positive. So which of those cases is this? The first one? They'll intersect because they have different slopes. Those have what? Same slope, but different y-intercepts, right? So this is the no solution case because these are the parallel lines. They have the same slope but different y-intercepts, so they will never intersect. Okay, next one, determining solutions from a graph. So to identify solutions to a system, it's where the graphs intersect. Now, if I have two lines, it's where both of those graphs, or two graphs, it's where both of those intersect. If I have three, it's where all three of them intersect. Okay, they all have to intersect at that point to be a solution. If I have four, it's where all four of them intersect. Okay? So now, one on the left here. See if you can come up with the solutions for that one. What are the solutions going to be for that one? How many and what are they? Once you get them done, check in with your neighbor. Make sure you guys are on the right page. Okay, check in with each other. And so for the first one, how many solutions do we have? 2. Right here, so that would be what? Yep. Negative 3, 0. This one is what? 2, negative 4. Okay, this one over here. How many solutions do we have? 4. So we got one there, one there, one there, one there. So where are they? Careful, it's not negative 6, it's actually what? Negative 5, comma 4. I know they're kind of small on yours. Okay, and then what? Negative 3, negative 4. Then what? 5, comma 4, and 3, comma negative 4. Okay, that makes sense? Now, let's say that I threw another line in there for that one. Threw that red line in there. How many solutions would that system have now? 2. If there's 3 graphs, it's where all 3 of them intersect. So this would intersect where? All 3 of those intersect there and there, just at those 2 points. Okay, so the more you add, the more you have to check all of the graphs where all of them intersect. Okay? That make sense? All right, so today we did graphing to find solutions. Okay, you should be able to figure out when just without even graphing, how many solutions the system is going to have. Right, looking at comparing slopes and y-intercepts. What questions do we have on this?